This lesson shows how to graph the rational function 4x minus 4 over x squared minus x minus 6. In previous lessons, you've learned about the four important parts of rational functions. The vertical asymptote is a vertical line where the function is not defined. The graph curves up or down as it approaches its VA. The horizontal asymptote is a horizontal line the graph approaches away from the VA, curving down from above or up from below. The y-intercept is where the graph crosses the y-axis, and the x-intercept is where the graph crosses the x-axis. This lesson shows how to graph the rational function y equals 4x minus 4 over x squared minus x minus 6, and variations of the function. The VAs are the zeros of the denominator. The factors of the denominator are x plus 2 times x minus 3. So the function has VAs at x equal negative 2 and x equal positive 3. For this rational function, the numerator is degree 1 and the denominator is degree 2. Since the degree of the numerator is less than the degree of the denominator, the HA for the function is the horizontal line y equals 0, the x-axis. To find the y-intercept, evaluate the function for x equals 0. This gives negative 4 over negative 6, which is positive 2 over 3. So the y-intercept for the function is the point 0, 2 over 3. The x-intercept is the 0 of the numerator, so this is a good time to factor the numerator. To find the x-intercept, set the numerator equal to 0 and solve. You get x equal 1. So the x-intercept for the function is the point 1, 0. Next, calculate at least one point on either side of both VAs. Starting at the left, for x equal negative 3, y equals negative 16 over 6. And there's a point approximately at negative 3, negative 2.7. For x equal negative 1, y equals negative 8 over negative 4. And there's a point at negative 1, 2. For x equal 2, y equals 4 over negative 4, and there's a point at 2, negative 1. For x equal 4, y equals 12 over 6, and there's a point at 4, 2. Finally, sketch a graph of the function. From this point, the graph couldn't curve up because there would be an x-intercept, so the graph must curve down towards the VA and up from below towards the HA. From these points, you can see the graph is increasing towards the left, so the graph must curve up towards the VA. Also from these points, you can see the graph is decreasing towards the right, so the graph must curve down towards the VA. Finally, since this point is above the x-axis and there's no x-intercept, the graph must curve up towards the VA and down from above towards the HA. So the graph of the function looks like this. Here are some variations of the function. If you increase the constant in the numerator, the graph stretches vertically. For example, you can see this branch of the graph is higher. If you make the constant smaller, the graph shrinks vertically. For example, you can see this branch of the graph is lower. If you replace the constant 4 with -4, the graph is vertically reflected. For example, you can see the right-hand branch of the graph has been flipped over and is now in the fourth quadrant. If you change the factors in the denominator, you can shift the VAs. For example, there are now VAs at x equal -4 and x equal +2. If you change the factor in the numerator, you can shift the intercept. For this example, the x-intercept at x equal +1 is now at x equal -1. For this variation, the factor in the numerator has been changed so that the x-intercept is to the right of both VAs. The left-hand branch of the graph doesn't change too much. For the middle branch of the graph, since there's no x-intercept, the graph curves up towards both VAs. For the right-hand branch of the graph, since there's an x-intercept, the graph comes up from below, crosses its HA, and curves back down from above towards its HA. This lesson showed how to graph the rational function 4x minus 4 over x squared minus x minus 6. This lesson was brought to you by the Math Fun Academy. Its continuing mission to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.